Hello，在我的频道常常会介绍一些科技竞赛，还有 SDGs 相关的一些议题。这一部影片呢，我会跟各位分享，我带着一群孩子去参加英国帝国理工大学所办的科技科学竞赛。那这个竞赛呢，其实它强调的是你要用科学和科技结合的手段去解决一个特定的环境或社会议题，并且从这个议题中你去找到对应的 SDGs或者是相关的一些概念。这部影片呢，其实我们谈论的是一个关于水稻跟碳排放的一个关系。很多人都忽略了农业其实它对我们环境的碳排占比是非常高的。首先呢，这是一个比赛，那我们是用远端参加的，所以它是用视讯的方式报告。那这个场合是在它的决赛。那我们这个报告的方式是先有5分钟左右的一个呈现之后，接下来它会有评审的问答，那我们就一起来看一下吧。
Sorry, I'm dyslexic, so I'm reading it like quite. I was going. It was all in chiral. Gets quite difficult. So, but Jess is most famous for her Wikipedia campaign as well. So she's probably very looking down there, being very modest. There, it's always very awkward when people. Next up, we have Dr. Eleonora Delia, manager for the faculty, the Department of Materials, and next up we have Becky Middleton, head of education. I should know because she's my boss, so I should be able to say this. So, head of education in natural sciences. She actually started this. So you've possibly seen every finalist that's ever been through. So wow, so that's like 10 years worth of finals. It's going to be an amazing show. We had the 4 to 11s this morning, the primary. They were unbelievable, and I'm sure you'll be equally as good. So without further ado, I should point out, you've each got 5 minutes, okay? Happy hackers, are you okay to get started?
Yes.
There we go. Brilliant. We will give you your 5 minutes, and the floor is yours. Go, happy hackers.
Hello, we are the Happy Hackers from Taiwan, and we would like to present to you our ideas and the purpose of our device. As you can see on the screen, this is it, the EcoRice O2 riser. Let us first introduce the problem, then go into the structure later on. The issue that we are trying to solve using this innovation is anaerobic fermentation in rice fields, which emits methane, contributing to global greenhouse gas emissions. The process is as follows. The bacteria in the water consumes up the oxygen made by algae in plants, leading to a deficiency in oxygen. Then this results in anaerobic decomposition, a breakdown of bioorganic materials in the absence of oxygen. This in turn produces methane in the reaction of methanogenesis. The GHG emissions are made of different manufacturing processes. Out of this, agriculture results in 21%. Inside the agricultural circle, 8% of this is interpreted as coming from rice fields. This calculates to 1.6%.
Rice does photosynthesis and produces oxygen as a byproduct. Then the rice and other aquatic life such as algae and bacteria use up the oxygen from photosynthesis and oxygen diffused from the surroundings to do respiration. During the day, photosynthesis is dominant. At night, photosynthesis stops, but respiration continues, meaning that the oxygen levels will be lower during nighttime. However, there's a problem during this process. When rice fields are flooded with water, it leads to the establishment of methane through anaerobic conditions. With the absence of oxygen, obligate anaerobes thrive in the flooded soil and undergo anaerobic respiration. Then the organic matter in the flooded soil undergoes decomposition, leading to the production of methane through a process called methanogenesis. Methanogenesis is when carbon dioxide and hydrogen makes methane and water. Methane is released into the atmosphere through diffusion from the flooded rice fields, contributing to greenhouse gas emissions. The methane produced from soil would also worsen the water quality. By pumping air into the water through our machine, the oxygen levels within the flooded soil increases. This oxygenation creates aerobic conditions, which are unfavorable for the growth of obligate anaerobes that produce methane through anaerobic respiration. It inhibits the growth of these bacteria and reduces the rate of methanogenesis. As a result, less methane is produced in the flooded rice fields. We've considered various scenarios that would decide the efficiency of our machine. During the sunny day, the machine utilizes direct energy from the solar panel to pump air into the water. During a rainy day, where there is no sunlight, the machine has paddles that cause turbulence for the water surface, enhancing the rate of dissolving of atmospheric oxygen. Some of the energy generated during the daytime will be stored in the solar battery. At night, the solar battery will be used to produce energy.
Now we shall introduce our device, which consists of mainly an air pump balanced on a boat. Our product utilizes a solar panel as the main energy source. In front of it is a small fan blade, which directs the direction of the boat according to the wind. The other hollow containers on the boat are simply supports for the major mechanical components. When the wind blows, the blades allow it to transverse across the surface and aerate different areas. Now I will highlight the main materials used to create it, including the pump, the fan blades, and a miniaturized solar panel. This totals to a price of only 13 pounds per device, and it can also be used repeatedly. Therefore, it is very useful in farming. This mechanism increases oxygen levels, decreasing the rate of methanogenesis, leading to clean water with less methane. These conditions are more suitable for plants, which can now lower carbon dioxide levels more efficiently. Therefore, it has been proven that our device qualifies as solving part of the SDGs 3, 6, 12, and 13. Last but not least, future applications. A method to use this technology in other industries could be in agriculture to help maintain the conditions suitable for cultivation, and water treatment, which uses aerobic treatment to purify the water using microbial organisms. Thank you.
Right, on time. I will hand over to our judges. I might have to relay them, through the microphone. So, judges, do you have any questions? I don't know if I can turn this. Have you had the opportunity to test your prototype in the field?
We didn't have the opportunity yet, but if we do have the opportunity, we're gonna use our machine and put it in a water tank, and we could use the collection of gas over water experiment to test out how much methane is produced.
That is for the solar panel, because obviously it was quite a small solar panel if you're going to deploy this in an ocean.
If I am correct, I'm pretty sure the price for the solar panel costs roughly £3.
Okay, so you could put a bigger solar panel on it without massively increasing the cost of your overall power generator.
Yes, but that would make it too big to transverse across the rice fields.
Okay, thank you.
Cool.
Following on that question, how big do you envision your prototype to be on the field?
Our prototype should be the width through the spaces of the crop.
Basically, like the size that it's shown, like that's roughly the scale.
Thank you very much. Happy hackers.
这个频道主要是讲科技应用专题以及一些升学上的资讯。如果你喜欢的话，麻烦订阅开启小铃铛。我们下次见，拜拜。